Okay, so our today's lectures are around the immunology. So of course immune system is one of the major organ in our body which is helping us against the microorganisms which are everywhere right now. We are infested by them. There are a lot of those present everywhere on our body. They are present in the environment. You touch somewhere, there are microorganisms. So microorganisms' job or objective in their life, in these little organisms' life, is to attack us, to be able to reach inside us and to be in there, to stay in there, to replicate and to grow. On the other hand, our body's job is really to keep preventing the microorganisms from entering our body and using us as a host. So this is a continuously going fight which is happening, and it is intriguing, it is exciting to actually see how our body actually helps us against those microorganisms. At the same time, being a doctor, what you would encounter is on the hospital floors that a majority of the patients you would have will have some sort of an attack, a successful attack by some microorganisms or infections with which they'll be presenting to you. So probably they would just come with fever or some other such symptom, but behind the scene there would be some microorganism which is attacking them. Similarly, you would also see another set of patients where immune system, our defense system which is helping to protect us, is now acting incorrectly, has gone weird and now either become lower in its function, or the function has increased, or the function has been directed to something which is really not harmful. So that means what you're going to get in the hospitals are two types of patients related to immunology or immune system. So one type of the patients will be those who actually have a microorganism which has attacked them, a bacteria, a fungi, a virus, a parasite, which has successfully attacked a person, has entered the body and is living there and is causing problems, and the patient has presented to you to help with that. That is one set. The other set of patients which would come to you, and very often, are going to be the ones where immune system has been operating pathologically. So it is not doing its function correctly, it is doing its function incorrectly. So in that case, the immune system has either gone less in its functionality and is not protecting the patient, for example AIDS, whatever is the reason that how the immune system got compromised, or the immune system became hyperactive and tried to send more protective molecules and cells our way than were needed and causing unnecessary damage to us. Similarly, sometimes immune system would also get directed against molecules which really are not harmful. So allergies are examples of those, in which case there are molecules which are attacking us or which are entering us or are present on our surfaces, are present in our lungs when we breathe, or present in the GIT. They are not really harmful, but our immune system takes them as harmful and starts attacking them back, and in that process starts damaging us. So without further ado, what I wanted to do was I wanted to create an overall picture of how the immune system actually works. What I've seen is that many times we look at the immune system in smaller pieces. For example, we look at the cells which function for the immune system, or we look at the molecules which are working in the immune system, or we look at various pathogens and how they are cleared out, but we do not see the bigger picture in one big view, and that causes us not to be able to connect the dots. So the very first lecture today, the importance of this is that I'm going to try to create a bigger picture of the immune system. So once we understand the bigger picture, then we would drill down into the individual areas and have more discussions about those areas. So let's start. So imagine that our body is like a city or like a country which needs to be protecting itself from foreign invaders. So that could be true for a city which is trying to keep peace within the city. That could be like a country which is trying to keep itself intact and prevent any foreign invaders. So to give us a bigger picture, imagine that here is the city. So this, all the area, let's say from here onwards, this is the city or the country. And now here there are sitting some very happy little microorganisms. Why they are sitting and why they're happy? Because they think that they are going to go into so they're really having fun. Why? Because they're going to attack this city and they're going to try to go in there and make it their host. So some of those viruses, bacteria, fungi, various such things, they're standing out here, they're really happy, they're going to attack. So the very first function of the immune system is to actually offer mechanical barrier. So that is the very first thing which happens. Our body offers mechanical barrier, or it offers strong walls to the bacteria and viruses and the fungi and the other pathogens which are trying to get into us. So the very first thing, the skin. So skin is keratinized. I hope you know this. Skin has multiple layers. The layers which are facing the surfaces or which are the outermost, these layers are keratinized, dead cells. So viruses and bacteria, they attack it, they sit down here, they're not happy anymore. Why they're not happy? So the marker. So why are they not happy? Because they're stuck here. They can't go any further. So the first mechanical barrier is the keratinization of our skin. That would also be, so if you say, well, you have the skin and that has a mechanical barrier, but how about the mucous membranes? They do not have any skin on them, or they have modified surfaces. So the mucous membranes with the modified surfaces, they have secretions in front of them, right? So most of the mucous membranes are wet, they're moist. So for example, eye surfaces or the GIT surfaces or the reproductive system surfaces or the urogenital system surfaces. So these surfaces are moist, and that moisture contains molecules and enzymes which can prevent a happy bacterium who is trying to attack us. When that comes over here, he is no more happy, because there are chemical substances sitting in here which would attack this, make holes in this virus or bacteria and try to damage it. Plus there are surfaces, for example lung or pulmonary surface, which has cilia on it, right? So these pathogens or these viruses, bacteria, microorganisms, they come and they get stuck in these. So this is also not a very happy bacteria or virus. Why? Because it got stuck into the ciliary surface, and now the cilia are going to propel it up and then it would be removed. So keratinization is one. There are moist surfaces. Then those moist surfaces have chemical substances and enzymes which can attack the bacteria and stop them. Then we have the ciliary surfaces, or we have surfaces with the cilia, and they can also be acting to remove the bacteria. Then we also have proteins called defensins. These proteins, what they do is they can identify a foreign pathogen, a foreign invader. They can identify that, and they can create holes in the